Our next panel is really focused on the implications of environmental policy, and we are fortunate to have Jennifer Morris and Sebastian Eastham with us. Dr. Jennifer Morris is a research scientist at MIT, Joint Program on Science and Policy of Global Change. Her research focuses on energy economic modeling, environmental policy analysis, decision-making under uncertainty, and linkages between human and natural systems. A key focus is investment planning for energy, water, and coastal adaptation. Jennifer is also a key contributor to the development of the MIT Integrated Global Systems Model, IGSM, focusing on the human component, the economic projection and policy analysis model. With modeling frameworks, she develops integrated economic and climate scenarios, exploring technology and mitigation pathways, and examining multi-sector dynamics. And Sebastian Eastham, Dr. Eastham, is a research scientist also at MIT. For the past decade, Dr. Eastham has been working to better understand how our emissions affect the overall environment using global-scale climate and air quality modeling. This has covered topics such as the effects of conventional and supersonic aircraft emissions on the ozone layer, the public health risks of geoengineering, and the side effects of agricultural waste burning in rural India. Across all of these topics, Sebastian has seen a need to consider pollution as more than just a local problem and is committed to understanding the ways in which the actions of one individual, sector, or nation can affect the people's health and prospects. Please help me in welcoming our two guests, Sebastian and Jennifer. Thank you.
So, where's the clicker? Thanks.
Green arrow.
Green arrow, excellent. Thank you for the kind introduction. As introduced, I'm Sebastian Eastham, and I'm going to be talking about, along with Jennifer, these questions of the implications of environmental policy. So, our focus at the Laboratory for Aviation and the Environment is on those informed decisions that we just talked about, on making sure that we actually know what will happen, or at least can try to understand what might happen when we implement a policy to try and bring about some kind of positive change. Now, my personal focus is on mostly air pollution with a little bit of climate on the side. So I want to know about, if we have some change in emissions, how will it affect our air pollution problem? Because we know that emissions are going to cause air pollution problems, and we know that emissions are going to cause climate change problems. That's really beyond question. But the difference with air pollution is that it's been relatively visible. If I live downwind of a coal plant and the smoke comes down into my backyard, I'm going to notice and I'm going to want to do something about it. And that has been a strong driver for regulation. So that's the relationship I'm going to talk about now, and some of the challenges that come down on us when we start to think about unintended consequences and how to do this in a nuanced way. So, as you might expect for a laboratory of aviation and the environment in a department of aeronautics, we worry a fair amount about aviation. Aviation, of course, has huge benefits. I don't know about many of you, but I did fly here today. I couldn't afford a sailor on a boat. And aviation drives $1.6 trillion annually in the US alone in terms of economic activity. And it's responsible for around 10.6 million US jobs, according to the FAA. Now, that's a serious economic benefit. So cutting down on that is something that's quite hard to do if you want to retain these benefits. But the fact is that it comes at a cost. Our studies suggest that aviation drives about 16,000 premature mortalities each year globally. That means a life cut short because of air pollution. Now, these lives are being mostly cut short as well in developing countries. That means that we reap the benefits without necessarily seeing the downsides. And policy is really the area where we can do something about that. The question is how to motivate people to do it. Now, aviation is one of these things which feels somewhat like a luxury. So let's talk instead about rural burning, the burning of agricultural waste in India. One of the projects that we've been considering in concert with the Tata Foundation is the problem of air quality in India. I'm sure you've all heard about air quality issues in, say, New Delhi, and the fact that India is seeing unprecedented levels of particulate matter pollution. And this is at least in part coming because of the burning of agricultural residue. We know that there are 2 burning seasons each year, that the air pollution gets significantly worse in a large tract of India every year immediately during and after that burning season. But we also know that trying to do anything about this is a very thorny problem. Naively, one might say, can we just ban agricultural burning? Well, no. This agricultural burning is necessary for the livelihood of a large number of people throughout India. And they are already under tremendous economic pressure as it happens, because they need to cram 2 seasons into a year of growing. And they only have a very limited time in which to clear their fields and turn them from wheat growing to rice growing. And frankly, the easiest, the cheapest way to do that in a limited time with limited resources is fire. But that fire, I don't know how clearly you can see it here. Those fires we can see from satellites, and they show up here as red dots. And they cause that smoke pall across northern India. From a satellite, this is in some ways the largest man-made structure visible from space, is the smoke palls rising up from these agricultural fires. So then you have the policy question. How do I improve air quality? How do I do something about the sustainability issue in a way that isn't going to destroy the lives of some of these people? We also have this question of transportation. We've spoken a fair amount about electric vehicles, and we see them as a necessary component of a realistic climate solution for the future. On top of it being a climate solution, electric vehicles could be a really important part of an air pollution solution. So in the US alone, we have calculated 50,000 premature mortalities, again, lives cut short, in 2011 because of emissions from cars, emissions of nitrogen oxides, of fine particulate matter. So the answer, hopefully, is to electrify. We can take those cars, we can say we're not going to drive them by burning gasoline in the car, we're instead going to charge it from an outlet. But that is a displacement. We still have an energy problem. Energy is needed to move that car, and that energy has to come from somewhere. And if that energy comes from a coal-fired power plant, and that coal-fired power plant is in the middle of a city, then you could end up making things worse. And this is one of those problems where you have to consider things together, and this is one of the things that we're trying to do, coming up with information to enable rational decision-making at the policy level, so that the solutions we put in place aren't, like was just said, worse than the problem. We can then start to think a little bigger. I've given you these examples which are, aviation is a very multinational problem, but it's kind of a small sector. Then we have these individual problems such as agricultural burning. What about something like the cross-state air pollution rule? One of the things I'm very glad to say that the Vola Foundation has helped us with is in looking into the implications of the cross-state air pollution rule. Now, I won't go into too much detail here, apart from to say that we have some very exciting results on this, which suggest that the cross-state air pollution rule can reap real benefits that start to dig into the question of what can I do as a state alone when I'm breathing the air that's transported over from my neighbors? How do I regulate in a way that improves my air when it's not my power plants? And we're hoping to have some data out very soon for you there. Please keep an eye. But what we can talk about is one specific sector. I mentioned earlier those 50,000 premature mortalities in 2011 resulting from emissions on the road. Now, if you think about NOx emissions and you think about the road, a specific company might spring into mind. And we might talk about how regulations are all well and good. We can debate policy until the cows come home, and we can write fantastic policy, but it's only useful if it's enforceable. And in this case, we have an example of US and EU regulations which were either ignored entirely, illegally, or worked around legally in a way which made them useless. And where in this one specific case, we had one company putting in place an emissions defeat device which resulted in likely 130 avoidable deaths in the US from just a few years of semi-legitimate vehicles. We also have the fact that this can spread. So there's been a lot of press about one specific company and the defeat devices that were associated with it. But we dug into some of those results and we found that it wasn't just one company. If you looked at in the EU specifically, we found that a slate of different manufacturers were all exceeding the expected limits for NOx emissions because there had been a culture put in place where it was okay to see these as not exactly a guideline, but something you just had to pass once and could then ignore. And this resulted in an estimated 2,700 premature mortalities across Europe. We published this paper last year as a result of these emissions regulations which could be ignored because they weren't enforceable in any long-term sense. So I don't want to be all doom and gloom. I do want to say that there are things that we can do. There are useful regulations we can put in place which can help to improve things for us. And we have a great example of that in Asia. From 2010 to 2015, I'd say that we've seen an increase in concern about air quality. We've seen an increase, hopefully, in concern about many environmental issues. And that increase in concern has been felt across Asia as well. And the fact is that as a consequence of policy improvements, most notably in China, there have been substantial improvements in the air quality in China. And the most important of those policies being to implement selective catalytic reduction on power plants. This removes the NOx that comes from those stacks. That improves the air quality, and that means fewer people dying. This means an environmental benefit for those people. But air quality has something to teach us as well when it comes to these climate questions. Now, air quality is usually considered, again, to be a local question. Climate is more considered to be regional or global, but air quality has regional and global considerations. What you can see here is a plot of the change in those nitrogen oxide emissions from energy generation across the Asia-Pacific region from 2010 to 2015. And you can see that there were these real improvements in China, mostly from those selective catalytic reduction techniques I was talking about. In South Korea, they also had an improvement in their energy-related mortality, but the fact is that the emissions in South Korea from electric power generation actually increased. And what we get here is this free rider question. Why should I act if my neighbor will clean up my air? And I'm sure this is something that you've thought about when it comes to climate change. Why should we do something if we can just wait for everyone else to do it? And you can see the inherent problems that come with that. So that's kind of a very quick overview of the problems that we're worrying about in the Laboratory for Aviation and the Environment. But now I'm going to pass you on to Jen, who's going to tell you more about the relationship between emissions and climate change and how policy can help us or potentially harm us there.
Thank you, Seb, for leading us off. So I'm going to get into the climate implications of emissions. And of course, we know that the climate is changing. And the latest global response has been the Paris Agreement, signed in 2016, in which nations have committed to action with their near-term commitments up to 2030. So if nations did actually follow through on these pledges to 2030, we could expect a flattening of global emissions, which is an improvement relative to what we otherwise would have expected in a world where there was no action. However, of course, the long-term goals of the Paris Agreement are to prevent the rise in global average temperatures from going above 2 degrees C and potentially limiting it to even 1 degree Celsius, which would require emission trajectories closer to the blue or the green lines. And so the key question here is, how do we get from where we are today, or where we might be in 2030, to where we need to be by 2100? And of course, there are a menu of different policy options that we can consider. Governments can think about directly spending money in some way. We do this through research and development, hopefully also demonstration and deployment, these direct expenditures. There's also loan guarantee programs for clean energy, tax expenditures, things like the production tax credits, investment tax credits that have been very popular for renewable electricity generation. Of course, the favorite tool of economists is the emissions price, which would place a price on CO2 emissions or greenhouse gas emissions in the form of maybe a tax or else a cap and trade system. We could also think about regulations, which has been the route that the US has been mostly going, things like the fuel economy standards, renewable portfolio standards, other mandates, of course, the ones related to air pollution and local air quality. And of course, there are also trade policies that can be engaged here, tariffs, border carbon tax adjustments that would be applied to the carbon content of imports. And so, as an economist myself, of course, I am a proponent of the pricing emissions as the most efficient way to address this problem. And so the question is, even if we could get our kind of ideal policy in place, a global emissions price that was designed to achieve one of these green or blue paths, emission paths, if we could guarantee these emissions paths, there's still uncertainty around what that would imply for the climate, for the economy, for energy, for human health, and other outcomes that we care about. So what are some of these key uncertainties? On the socioeconomic side, of course, how is population going to grow over the rest of the century? How is GDP growth going to grow? How much are technologies going to cost? What can we expect in terms of energy efficiency improvements? Fossil resource availability, if fossil might get more reserves, we could find more sources that could make fossil cheaper and make the problem even harder to solve, right? So there's all these important uncertainties on the socioeconomic side, but also on the climate side. How does a given amount of emissions translate into temperature impacts, precipitation impacts, other climate outcomes that we care about? So all of these things are uncertain, and uncertainty, of course, can be paralyzing, but we cannot let it be an excuse for inaction. And instead, we need to embrace uncertainty, we need to try to quantify it, and use it to help us make decisions. So that's what my group at MIT tries to do. We try to establish, quantify these uncertainties, establish probability distributions for these key uncertainties, and feed those through our model of coupled human-Earth systems. So the work that I'm doing involves establishing these distributions for socioeconomic parameters, which we sample and we pass to our human activity model, which is really capturing energy and economic decisions. And where that model is projecting future emissions, which we pass to our Earth system model, which is capturing atmospheric chemistry, ocean dynamics, land dynamics, and we're also sampling from the climate distributions. And together, we're getting these integrated projections of the economy, energy, and climate. And we get probability distributions of outcomes that we care about: temperature, precipitation, policy costs, energy mix. And so as a way to kind of communicate this type of research, we can think about what would be the temperature implications of a no policy world where we don't take action. And so we've developed these greenhouse gamble wheels. And so this wheel, it's like a roulette wheel. This is essentially the wheel that we're spinning as a globe collectively today. And you can see here that there's no probability of temperature being below 2 degrees C. In fact, there's high probabilities of very high temperature outcomes. Now, if instead we could commit to that 2 degrees C emissions path, or a path similar to that, this is the wheel we would be spinning, which would have a 66% chance of keeping global temperature below 2 degrees C. We still can't guarantee that we would be below 2C with any given emissions path, but a 66% probability is pretty good. The question is, which wheel would you rather spin? And as someone who works a lot with climate scientists and what we have heard before, I can tell you I'm terrified of that wheel on the left and would much rather be spinning this wheel on the right. So then the next question is, how much does it cost to spin that wheel on the right? And so our modeling exercises try to quantify this. We measure the global policy cost of meeting a 2 degrees C scenario. And here, the definition of policy cost is the change in economy-wide consumption, which is a measure like GDP, in this 2C policy world compared to what it would have been in a no policy world. And so the distribution of policy costs that we find globally range from about 8% loss in total consumption globally to 15%, with the median around 11%. And so to put this in a little bit more context, while it's a loss compared to what would have been in the absence of policy, global GDP would still be growing in this case of significant emission reductions. It would just be growing slightly less than it would have been if we did no climate action. And so how about for the US in particular? If the US policy costs that we estimate in this global effort to meet a 2C policy are much lower than the global average, and we're seeing in the range of about 1 to 4%. And to provide context there, the latest National Climate Assessment and another recent large study estimated the cost of global climate damages to the US in particular to be about 10 to 10.5% of US GDP. So we're seeing that the costs of climate damage caused by climate change, are much higher than the cost of mitigating those changes. So another question is, what implications does following this type of policy have for the energy sector? Here is one example of the type of energy transformation that we would need to undertake. This is the global picture, and of course, we need to drastically improve energy efficiency, a drop in total amount of energy use, and the sources of energy. Here we're showing electricity, a lot coming from solar, carbon capture and storage technologies, nuclear. The exact mix of the technologies, of course, is uncertain depending on how the costs pan out, and we also try to quantify that and look at technologies that are most robust to the different types of futures we might see unfold. Some overall implications that we see are that no matter what, the portfolio of energy technologies needs to be diverse. We can't count on any single technology. We should be investing in the research and development of several of them, not counting on any one silver bullet. And the exact mix is going to depend on several factors, including which technologies are available, how much do they cost, and how much do they cost relative to one another. How quickly can we expand a technology? We can develop these cool new technologies, but do we have the expertise to deploy them quickly? Public acceptance, which has been challenging for some key technologies such as nuclear, carbon capture and storage. Can we change people's perceptions of these technologies in a way that will help gain support for their role in the low carbon future? And of course, the specific design of policies and their stringency is also going to affect the energy mix. So that loops us back to kind of the beginning and to say that our overall points is that the design of policy is going to have important implications for the climate, the economy, human health, the energy mix. And another key takeaway that really would like to emphasize is that uncertainty is undeniable, but we can embrace that uncertainty, we can quantify it, and we can use it to help make our decisions and to identify actions that will help us avoid the worst impacts. So thank you for your attention and enjoy the rest of the conference.
Phenomenal. I always find these scientific presentations with kind of a sense of hope, right? We have some amazing people who are doing the hard research to figure out what policies we need to work on, and that guides decisions for governments like Orlando and others to figure out what's the most impactful thing we have to do. So thank you both for the research that you're doing.